Alright guys, here's your Chapter 4 right triangle trig test review video. So let's get started. Number 1, choose the correct quadrant for angle alpha that fits the following description. So we have the tangent is greater than 0, so that means the tangent is positive. And we have the sine is greater than 0, so we know the sine is positive. Okay, so now we have to look at our ASTC. We have to figure out where both the tangent and the sine are positive. Well, the tangent is positive here and here. The sine is positive here and here. So the only one where they're both positive is quadrant 1. Okay, quadrant 1. So the number 1 is A. All right, now, number 2, choose the correct quadrant for the angle alpha that fits the following description. The cotangent of alpha is positive. The cosecant of alpha is negative. Now remember, the reciprocal trig follows the same pattern as the normal trig. Alright, so since the cotangent is positive, that means the tangent's positive. So we're positive here and here. Now the cosecant is less than 0, so the cosecant is negative. The cosecant goes with sine. The cosecant is negative. Oh, the sine is negative here and here. Alright, so they're both negative in quadrant 3. So the answer to that is C. Alright, moving on. Let me clear this out. Number 3, solve for x and round your answer to 1 decimal. Alright, so what we have to look at here is what sides we have. Alright, well this is our angle down here, 50 degrees, and we have this side here, which is on the opposite side of the triangle. So that's the opposite side. And then the side x here is opposite the 90, so that's the hypotenuse. So you have to go back to SOHCAHTOA, okay, and figure out we have opposite and hypotenuse. So sine is opposite and hypotenuse. So the sine of 50 degrees equals 3.9 over x. Now, if you remember, the shortcut way to do this is to just switch the x with the sine of 50. So x equals 3.9 divided by the sine of 50 degrees. Now, before you go punching this off into your calculator, check your mode to make sure you are in the correct mode. Because, of course, if you're in the wrong mode, you will get the wrong answer. Alright, so 3.9 divided by the sine of 50 is rounded to 1 decimal place, 5.1. Okay, 5.1. Alright, now let's look down here. Here, this is our angle alpha. Here, this is the opposite side. This is the hypotenuse, so again, we're using sine. So we know that the sine of alpha equals 7.4 over 8.4. Alright, now, since we're trying to find the angle itself, what we're going to have to do is take the inverse sine of 7.4 over 8. So inverse sine of 7.4 over 8.4. And again, it says angle in degrees. So make sure your calculator is in degree mode. If it's not in degree mode, you will get the wrong answer. So always make sure you are in the right mode. So the inverse sine of 7.4 over 8.4 is 61.8 degrees. All right, 61.8 degrees. So again, always double check your mode to make sure you are in the correct mode. All right, moving on. Number 5, solve for alpha. Express your answer in degrees and round to a single decimal place. So here's our angle. This is the opposite side. This is the adjacent side. If you go back to SOHCAHTOA, opposite and adjacent, that's tangent. So we know that the tangent of alpha is going to equal opposite over adjacent. So 5.8 over 6.3. Again, you're going to have to do the inverse tangent. All right. Now, to know when you need to use the inverse and when you need to use the regular, when you're trying to find the angle, you got to use the inverse. Okay. That's the only time you use the inverse is when you're trying to find the angle. All right. Again, can't stress this enough because I saw some of y'all doing this in class. Cannot stress this enough. Make sure that you have your calculator in the correct mode. If you don't have your calculator in the correct mode, it will not give you the correct answer. So the inverse tangent of 5.8 over 6.3 comes out to 42.6 degrees. All right. All right, number 6, here's our angle. So that means this is the adjacent side, and this is the hypotenuse. So, SOHCAHTOA, that means we're going to use cosine. So the cosine of 32 degrees equals adjacent, which is 6, over hypotenuse, which is x. Remember, switch the x with the cosine of 32. So x equals 6 over the cosine of 32 degrees. Punch that into your calculator, and you should come up with 7.1. Okay, 7.1. Alrighty, moving right along. Number 7, give the reference angle for the following angle measure. Remember, reference angles is the measure between the terminal side of your angle and the closest x-axis. So 39 degrees will be down here. 239 degrees. So it starts here and comes all the way around, right? But now our reference angle just starts at 180 and goes down to the 239. So to find your reference angle, take 239 and subtract it from 180. Okay? Take 239 and subtract it from 180, and we will get our reference angle as 59 degrees. Okay, so 59 degrees. So I'm going to erase this. All right, you do the same thing for all of them. 99, that is in the second quadrant, right here. So again, your reference angle is right here, so you're going to do 180 minus 99. Okay, and that'll give you your angle, which is 81 degrees. So our reference angle here is 81 degrees. All right. All right, number 9. If alpha lies within quadrant 3, okay, so our angle is here somewhere, and the sine of alpha is negative 0.507, find the cosine. All right. To do this, you're going to have to use the golden rule. You're going to have to use the sine of alpha, sine squared alpha, plus cosine squared alpha equals 1. Plug in your sine, negative 0.507 squared plus cosine squared alpha equals 1. Subtract the negative 0.507 squared from both sides. So the cosine squared of alpha equals, let's type all this in, 1 minus negative 0.507 squared. So the cosine squared of alpha equals 0.74295. Take the square root of both sides. and the cosine of alpha will equal 0.862 because I asked you to round your decimal to 3 places. Okay, this is number 9. Number 10, actually, we're not done with number 9 yet. Remember how our angle lies in the third quadrant? Well, the cosine is not positive in the third quadrant, so that means this has to be negative 0.862. Okay, the cosine of alpha is negative 0.862. Okay, you have to use your negative answer because it's in the third quadrant. All right, now we have the cosecant and the tangent. So we're going to have to use a cousin of the golden rule. The easiest cousin to use would be 1 plus cotangent squared alpha equals cosecant squared alpha. Okay, 1 plus cotangent squared alpha equals cosecant squared alpha would be the easiest one in this case to use. All right, so let's fill in our numbers. 1 plus cotangent squared alpha equals 8/5 squared. Yes, I would recommend keeping this as a fraction. So minus 1, minus 1. So the cotangent squared alpha equals 64 over 25 minus 25 over 25. All right, which is, what is it, 39 over 25? So the cosine squared alpha equals 39 over 25. So now we need to take the square root of both sides. I'm sorry, that's not the cosine, that's the cotangent. What am I doing? That's the cotangent, not the cosine. So now take the square root of both sides. So the cotangent of alpha equals the square root of 39 over 5. Okay? Square root of 39 over 5. But this is in quadrant 2. So in quadrant 2, the cotangent is negative. So this will have to be negative square root of 39 over 5. But we also wanted the tangent of alpha anyway. So the tangent is the inverse of cosine. The reciprocal of cosine. So this is going to be negative 5 over the square root of 39. And of course, you're going to have to rationalize your denominator. Okay. So to rationalize your denominator, you multiply the top and bottom by the radical in the bottom. So that's going to give us negative 5 times the square root of 39 over 39. Okay. I'm going to write that a little bigger up here. Okay, the tangent of alpha equals negative 5 times the square root of 39 divided by 39. Okay, that's the answer to number 10 right there. All right. So don't forget how to use your Pythagorean. They're called Pythagorean identities. The sine squared plus cosine squared equals 1. That's a Pythagorean identity. And then you have your two cousins, which is 1 plus cotangent squared alpha equals cosecant squared alpha, and tangent squared alpha plus 1 equals secant squared alpha. Okay? Don't forget those and how to use them. Don't forget to read the quadrants and make sure you're putting the angles in the correct quadrants, and therefore getting the right sign, not as an SINE, but as an SIGN. Make sure you're getting the correct positive or negative number. All right. So that's your test. That's your test review. Make sure you're ready to go tomorrow when you walk in. See you tomorrow.